Is it 1 or 0? No, I'm not. You guys are not sure. Is it 1 or 0? Okay. So we have 47 training examples and 2 independent variables x on the first and second column, and 1 dependent variable y on the third column, right? So I said, recall, our untrained model is given by where? Thank God there's nothing there. What is it? There's no picture now. Oh yeah. I thought this last week. Well, open the old code. Open the former code and check for it. Let's see. Eh? See now I'm bouncing because you guys know. So which can also be written as? Me myself, I don't know what to say. But I know I know something there. Where y is what? X is what? Theta is what? So what are we updating when we are trading? Why are we updating theta? Why are we updating theta?
To get to the local
Okay, so I can copy and paste. That's why we are seeing 97 here. You know 97. What's our value of m? So what's next? From what we did in the last class, I did a lot of copy and paste. So from what did we? What's next from? So what am I doing here? Sorry. Come in, guys. Okay. I've seen what I did. Sorry. Okay, so we are still on track. So what's happening here? Why are some people doing You will notice some differences here from what we did last time. It's just minor things that we've already discussed about and things that I've already done. If you did John's assignment, sorry, can I close? Thank you. So what's happening here? Have you seen this function before? So you are just picking the column. So remember data holds. What does data hold? It's a variable that holds what? Are you guys seeing and not seeing? Data. What does it hold? So it holds what's the name? The data set. The first column is what? The size, right? The second column is what? The number of bedrooms. The third column is what? The price. So now, what am I doing here? And so I'm picking all the values in the first and the second column, and I'm saving it in what? So I'm separating my x from my what? So what am I doing here? Not the second, the third column, right? So I'm taking it and I'm doing what? Saving it. So this will be what? What will be the shape of this?
7 by 2.
Right. Who doesn't understand? Zero to one. How?
Instead of writing
so this is non-pi underscore. Collect all the columns. This is like select from columns, right? So now you are saying the column or from this variable data, right? Or this data frame data, all the rows, right? For column 0. Column 0 is the first row. And for this one, all the rows column 1. So it brings two of them together.
So if I'm selecting like 5 kilos, that means I have to write 45 minutes.
But the other ways of doing it.
Okay, so that way is what I'm actually.
I want to use
I will search the system now. They are different. So if you remember in the last class, I didn't use this. I used something like H-stack, right? Something like H-stack, I used a different method from this. So there are numerous methods you can use to pick up the values of X. Right? So for the guys who are new in the class, it's going to take a lot of time for me to explain everything from scratch. Am I right? Yes. So what can happen is there are people in class who know all these things. So you can just meet them, they'll just explain. Where is time? No, let's move on. I'll find you. But just listen to yeah. If there's any backlog, I'll try. So now, guys, okay.
I guess we should group ourselves like.
So I think that's the best. I'll group everyone, study groups.
Yes.
So if you don't understand something, ask people in your study group. When nobody in your study group knows it, I don't know what to say. Yeah, you can do that. So I put no numerous, you can do that. You can do that. So that's that. So we have our X and our Y, right? Guys, so we have our X and our Y, right?
Yeah.
Okay, so there are some things here that don't really apply to this class. So like I said, this code is from the class I taught last 4. So I visualized it later, right? And then I was trying to show them some things. So if you see, here I'm plotting the room size against the price to see how they correlate, right? Huh? Last. No. It depends on how your data is. Why can be anywhere? It can be anywhere. Huh? The actual y. Position of y. Position of y. Based on your data set. Just like Excel. Wherever you put something, wherever you name it column, that's where the column will be. So in this case, y is the last. Y can be the first, it can be at the center, it can be at the middle. Just know where the position is going to be down from there. Right? So now I plotted the room size against the price to see how they correlate, to see how they are related, right? So what can you see from this data? This is the price, this is the room size. Huh? Yeah, that's the correct answer. So they are positively correlated, right? Positively correlated. So as price increases, what happens to the room size? It increases, right? So for the number of bedrooms, why are we having the data like this? So it's the same thing as room size increases, price increases. But the reason why you're looking at it, you're seeing it like this is that the room price is not a floating kind of value. It's not it is either 3 or 2. You don't have 3.5 number of rooms or 4.5 number of rooms. Do you get what I'm trying to say? Yeah. So it's either 2, 3, it's in categories, passes. 2, 3, 4, 5. You get. But a 5-bedroom house is what's the approximate 700,000, right? So that means that the number of room increases, the price increases, right? Okay, so there was even a class discussion. What do you notice from the 2 blocks? What do you guys notice from the 2 blocks? Nice. Second, any other notice? Do you notice any other? Huh? So the major thing is that they both have positive correlation. But that's the most important thing. So now, do you think any reasonable model can be created?
Yes.
Yes, because there's a reasonable relationship between the data. Right? So, just ignore this. Yeah? No, that does not mean. So negative, your model will be able to find out. Sometimes the model will be able to find out what is happening with the negative correlation. So that does not mean that you just throw it away. Right? So here, I was just trying to show. So you know we have two values of x and one value of y, right? So now we can plot it. It's a 3-dimensional data, right? Yes. So we can plot it and see what it looks like. So in the last class, I plotted it and I asked them. What I asked them is what I'm going to ask you. What do you understand from this? Yeah? What do you understand from this? I know this 3D. No, you're getting it now. And the past is reducing. So what do you guys understand now? Gradient descent. Gradient descent. And so this is your price, right? This is the number of this is the size of rooms. So what do you understand?
size of area.
And area is size.
Of each of the rooms.
Yeah, so all these points represent one. Yeah, one data point. So what do you understand? So we don't waste our time. There's nothing to understand from this. That's the essence. There's nothing. So the reason I do this, look, people are fond of drawing from mad 5D drawing, right? And you don't understand anything, right? There's nothing else you understand from this one. Why don't you just close it one by one, or use the other functions that controls everything one by one? You want the first one that we did, these guys understand some stuff out of it. Yeah. Right? So I don't know what's the name of this cartoon or Dexter. Maybe there's one Dexter here that will see that just know how to take it. So that was the point of this. So now, feature normalizing. Who practiced the feature normalizing stuff we did last week? That's 2 weeks. It was an assignment to find it. So, feature scaling, feature normalizing. So, who practiced it? I know there were 2 methods that we mentioned that on that day. What was the first method? Huh? Standardization. To me, there are so many English for different things. So what do you do? What does standardization do? Is it the one where you divide the value by the maximum value? That's another one, right? So there are 2 methods. All those words, standardization. Another person will tell you that no, our tester did not say standardization. It is that's the other one. So the first way you can normalize is this. You divide all the values in that data set or in that column, right, by the maximum value on that column, right? So if you have a data set, like in our own case now, we have room sizes, different room sizes, right? And then the largest room size we have is 60,000, right? If you divide everything on that column by 60,000, what will be the maximum value we will have? 1. Right? So everything will be 0.0.0.0.0. That way we have normalized to reduce the values. I'll explain why we are doing that, right? Another thing you could also do is using this formula. So you calculate the mean. Which one? Who wrote this one? It's wrong. So, was I sleeping last night? So, it is the value, if it is x, the value of x minus the mean, all over the standard deviation. Right? So, that's another way of normalizing it. So, it reduces the values, those large values that you have. So, if you check up, if you check up, see the values of our prices. You can see how large they are, right? See the values of our room sizes. You see how large they are. If we use these values the way they are to train our model, what do you think will happen? What do you think will happen? Josh said it in the last class. What do you think will happen? It will take a longer time to converge. So it will take a very long time to reach that local minimum. You get. Apart from that, it will require a larger computing power to get to the local minimum. You get. So when you reduce it, it does calculation faster than large values. Okay, since you people don't understand what I'm trying to say. 39900. This practical example. Everybody are going to solve it. 39900 times 2104. Calculate it and calculate 2 times 4. So you want to calculate the way this time to calculate this one. But now you get what I'm saying, I mean? So, okay. So now, okay, so let me write the real formula for you. Don't ignore that formula there. It's not very strong for Akon. It's not that it's okay. It just depends on how you want to do it. For me, I prefer this one. I prefer this one. You can actually use any one you want. And also it depends on the kind of problem you are solving. Right? But for me, or generally, it's this method that is used. Me, the value might just be mean all over the standard deviation. I prefer this method.
My question is, I didn't get this question.
So it says, when do we know when to use this? And when do we get to use
I have a question.
this one?
I was thinking about like this between maybe tends towards 0 and 1, maybe value change 0 and 1. Okay, that's the equation to that.
So that's what I said. If the maximum value in your column is 600 or 60,000, and you're dividing every other value by that maximum value, what will be the maximum value after you?
Is it the same thing with soft math?
No, it's not. Don't ask me what the software is. It's not got to do it. So now we've written a function to do that. So don't mind all the green, black, red, and blue colors they are seeing here. It's just the same formula I wrote here. This one here. This one here, right? So what we do first is we pass in the value of x, right? So all those numerous things that we calculated, we pass it here, right? Then we just copy it to a new variable. Do you get? So or you could still use this one straight away, but I decided to copy it to a new variable, right? After copying it to the variable, I calculated the mean. So NumPy has a function to calculate the mean. So you just do np.mean, and then you pass in the data set. So after calculating the mean, right, I calculated the standard deviation, right? So what's next? If I calculate the standard deviation, I have the mean, I have the standard deviation. What do I do next? Eh? Okay. So after passing this one here, right? So after getting the mean and the standard deviation, what happens next? The formula. Yeah. So this is the formula, right? The data minus the mean divided by the standard deviation. So NumPy does divide. That's what we are using to divide. So you're saying the data minus the mean all over the standard deviation. That's what the comma is. You get, right? So now we have our normalized mode. What do we have here? You don't understand it. Is that you don't understand it? It's straightforward, right? So now we have our normalized value of what? X. Now, can we use this X this x, right? Can we use it the way it is? Now it's just x of x1 and x2. Can we use it like that? Now our what's the name? Our model is not more this way. It's not more theta 0 x0 plus theta 1 x1. What is it now? What is it now? You get why is this, right? Because we have two features, right? That's why we're having this. And now our variable x norm holds only this and this. So from what we've been doing before, what do we do to the vector? No, it's not the vector now, the matrix x. Now the matrix that has both x1 and x2. What do we do to it? Nice one. So add our x0, right? Yes. So that's what we did here. So immediately after normalizing it, before you send it out, right? You stacked ones to it. So now this is another way of doing it. Different from the one that we did before, but you can still use the one we did before. Here, right? So now, this is our x norm. I'm now saying that first things first, I'm creating what? A vector of ones, right? I'm creating a vector of ones, and then I'm concatenating that ones vector to my x norm. Do you get it? So everything here is creating 1, 1, 1, 1, 1. We did it differently in the last class. This is another method, right? So now we are creating 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, up to 47. So that's why we are doing dot size here. Do you get it? Don't worry, the code is there for you guys to run step by step, step by step, step by step. Okay, I should do it again. Should I explain again?
Yes.
So now, we want to concatenate. So you know what? Do you know what concatenate means?
Yeah, join together.
Concatenate means join together, right? So what do you want to join together? So if guys, so if we have x, these are x1 and x2. How do we bring our x0 here? It's not just to join x0 to this. So that's what concatenation means, right? So what concatenates a vector, guys? Want to concatenate a vector that contains 1, 1, 1, 1, 1, up to 47, right? We want to concatenate it to this matrix, right? So when we concatenate it, what will the shape be? 47 by what? You guys are too good. The notebook. I'm not saying the notebook yet. Okay, so that's what we're doing here. So this from this code here is going to create a vector of ones, right? And we are concatenating it to x norm. Do you get now?
So I have a question. This x underscore theta, what's that line doing?
It's just getting the shape.
Okay, I think dot size is the shape then. What is the one
I think it's by column. Let me see if you guys want to do one by guys, look up. 24 by 1. What is it? Okay, guys. Are we there? Or are you tired? Are we looking at the phone? Yes. Okay. So let me explain step by step what this thing is doing. Okay. Right? So remember I said it's doing what? What is this doing? Creating one vector of 1. Right? So let's take it step by step. You don't understand the code, or you have forgotten how the code was working. We'll take it step by step, right? So now, if we take this is what creates the one vector, right? Huh? Oh, kind of. I said so. This is what creates the one vector. One vector, right? So what do you think this is going to give us? What do you think it's going to give us? Okay, so what do you think this is going to give us?
Capture the 47 and add the 47.
So what do you think? What will? Oh, is even the answer is there. So what do you think this will give?
This is just to capture all, not adding anything.
This.
Yeah.
No. What is this going to give? So it's just going to give everything in the row.
Everything in the row.
So this is for all the rows in the first column, right? So when we do dot side, it's going to give us 47 because it is 47 by 1. So but if you do dot side, right? What do you think it will give us? 47 too. If for some, if the person who will get it, I'll give that person.
Sorry. Can you run it without the
Eh?
Can you run it without the
Dot side.
Can you run it without
Okay. Right? Okay, so
I want to just X underscore data. That's the column, comma.
yes.
Well, how do you say it? Thinking.
Okay. For all the rows in the first column, select for all the rows in the first column. So,
Sorry, in our last class for data science, people that were here for data science, we did something like fruits, and we get that concept, and it brought everything out. Okay. So, in this part, that 0 is for column. So, if you put more, now you're going to bring in another one.
okay. So, what is this going to give us? I'll give the person. This is. The person who get take your time with now. The person who gets it, I'll give that person a paper with my signature there. I know he has gotten it. I'm not doing it. He got it. It's 94. So it's 47 times 2, right? We didn't select anything. So it's everything. This is a 47 by 2. So 47 times 2 is what? So what if I do? Will he run? Will he run? I don't think it's run. It's actually run. I thought it's a panda stuff.
Well, what of if you say dot reshape? What will you do?
Dot reshape. So you're doing dot reshape is you want to change the dimension.
It will be 2 by.
Do not put in brackets what dimension you want to change. Where? This one doesn't require this. That's how the owner of the function. Okay, let's try it. Let's try it. Let's see. Okay, so now, you understand this, right? So now, we know that what we are getting here is what? 47. Right? Comma 1, what does that mean? So it means create a numpy of 1s that has a shape of 47 by 1. It's a vector now. 47 by 1. You get it? So if we run this now, what do you think we'll have? Right?
Yes.
That does not mean you will do your assignment. So we have to understand this, right?
Now we want to see the change. Does that mean you are adding the matrix instead of
No, so you won't add 2 because if you remember, the coefficient of theta 0 here is 1. It's 1, right? It has to be 1.
No, I'm talking about that NP dot was
Which one?
That?
This one?
Yeah, that one.
I will not try it. But I don't think they will give you anything. It's 1. It's surely 1. So, Bob,
I have one question.
for feature normalization, many questions. Okay.
See, I'm not thinking of after that discussion now, and we just put in a one. What will happen?
Where?
That X underscore data, square bracket, column, bracket, comma, 1.
1.
Yeah,
It will still work because now we are getting the size. The column 1 still has 47, right? It still work.
So that means, what we, okay, let's just use this as an example now. For this one now, what is going to give us is for the X1. If you should put 1 there, then it will give us for the X2.
So, no, you're not getting the point. I can as well clean up this I've written here, right? And put 47 with my hand. You get it? But the reason why I'm doing this is that this is a very small data set. If you're working with data set that is 655,574 something. Do you want to start cramming the words one by one? No, right? So you just do this dot size, the number of rows, dot size, and then you move on. Yeah, you can use your time for better things than checking how many it is and writing them in the paper. You get my point, right?
Yeah.
So then we return what? The new x that contains our ones, the normalized x and our ones, right? The mean and the standard deviation. So this is just so that we see what the mean is and the standard deviation is. Right? So now when I normalize, I just passed in x data. Remember x data is that numpy that we created, right? That has all the big values. And then when we passed that big value into this feature of norm, right? This function that we just created. It will return, once we run this, it will return x, the mean and the standard deviation. And if we see the mean of the standard deviation is what? This is the mean. So the mean house is what? The mean room size is what? And the standard deviation of the room size is what? The mean number of rooms is what? 3 basically. And the standard deviation is what? It's not 0, 0.7. Right? So now let's see what the data looks like. So you find out that those big values are gone.
Well, also if the standard deviation is 0.1, do we increase it or we just
Use it like that.
Okay, we use it.
So now let's see what x looks like. So let's print x, 5 values of x. Does it make sense? Does not make sense. Let me print bigger for the ladder. Why did it bring just 1, 2? Oh, how did it do the sum? So you can't do the sum.
X, 1.
I'm trying to print the test file. I've forgotten the function. No, this is not quite. Don't worry, let me just print this file. So, don't worry. Okay, do you understand what this is now? You don't understand? What is all this? 1, 1, 1, 1, 1, 1, 1. Abi? What is this? Our normalized values of number of rooms and does it make sense? So, but if we were using the value divided by the maximum, would we have negative? Right? So now we go down to training. So this is the same training thing that we did the last time. So that's the same functions that we used. Is there any difference? Guys, is there any difference? Is there any difference? Is there any difference? What's the difference? Eh? There's no theta. 3 exactly. So why is it 3, 1? Because we have 3 values of theta. Right? You understand, right? Theta 0 is the coefficient of 1. Theta 1 is what? Coefficient of 2, which would be our Number of rooms. Theta 2 is what?
Coefficient of room size.
Room size. So we initialize it to 0, huh? Just like we did the other time. And I remember clearly that in the last one, we did it with our hand. We just put 0, 0 in. So if you have a larger number of theta, you can just use non-pi of zeros. So I don't know if there's twos, so these zeros, these ones. Zeros, twos. Right?
Sorry, I have a question.
Okay.
I was just going through some of
They can't hear you.
I was going through, I'm just going through the code and I just saw something now. Sorry if I take off PLC command by master data
That's
dot
visualization.
log. No, I know that data dot log. What does it do?
It works there. You are picking, it's just selecting data from the columns of your data. Run it separately. Okay, so walk me through this. So now, I want to learn from you guys. I want to learn from you guys. So explain this thing to me. I don't know it. Who can just volunteer to come and explain it? I know I've taught it 4 times. Oh yeah, now it has evaporated from my head. Nobody. But yeah, just try, please. Just somebody should try. Yeah, thinking about it. Yeah. My guy. Fresh. Just try. You don't need to do it. Just try. No, just try. Have you gone through it? You were in the last class. You were in the last class. Right? Some of yeah, just try. Don't worry, they won't laugh at you. I almost try. Yeah, just yeah, the trip
So explain it with master.
No, you can be using it. Imagine it's king.
So iteration. That's okay. First of all, we have the input arguments. That's the x is our input data, the y is our output, our target. So that's our target, not our output now. Why is our target? So we have iterations 1000, which means we are updating our data 1000 times to try to train the model. Then we initialize data, like I said. So data here is a vector with 3 rows, 1 column, and it's filled with zeros in initialization. And then we initialize our cost function vector, which is all zeros iteration. That's 1000 slots. So basically, what this is because we will be writing it with our new cost function at every iteration, and so we now have our iteration for loop. So am I everybody with me? So I have our iteration for loop, and so the first step here is to do this dot product. So H is our output, that is our assumption by iteration, and H is equals to X at theta. So theta is the dot product of, the at operator is the Python dot product of theta. And what it just does is, it takes our theta, which is an array with, a vector with 3 elements, and it finds the dot products against X. So just like we do matrix multiplication, we have theta 0, theta 1, theta 2. And then, for example, we have our x, it has 47 elements. So let me just, I don't know, let me just say A, B, C, D. Okay, so the way this works is just like matrix multiplication. So we have, okay, I reversed it, sorry. This should come on the other side. This should come on this side. So the way this works is just like matrix multiplication. So we have A times theta 0, which is x0 times theta 0, and then we add it to E times theta 1, which is x1 times theta 1. So this is our output. I thought there was a
Please listen to him. He's very, very correct. No, I'm serious. And he's doing it better than me. Those guys go this quiet in his own time.
Okay, so this is our output matrix H, and then we now have in the first column, in the first row rather, we have A times theta 0, which is x0 times theta 0, which will be here, but plus A times theta 0 plus E times theta 1, which is x1 times theta 1, which will also come here. And I times theta 2, which is x2 times theta 2, which comes here. So basically, the add operator just does this to the whole 47. So we have the first row of H, it does this again. B theta 0, F theta 1, J theta 2 has it until we get the 47 rows on our output vector, so that's H. And then we then pass those three values, the H, the theta, and the X, to our update weight function, which has the formula that we use to update our weights. And that gives us a new value for theta, right? So our next assumption for theta, and then we calculate the cost function and give the value into the cost function array for each iteration. So we do that 1,000 times, and after 1,000 times we end the training, and then we print out our results.
Okay, so who understands what he said? I was listening with my other ear. Did you guys understand what he did? understand this, right? So what are the questions? Okay.
I understand that there's an object with function.
Yes, yeah.
That object is calculating theta and x.
No.
Yes, ma'am.
So it is update weight function. So theta is what? What is theta? Theta is a weight.
Well, I don't know. You're like using theta to obey the three of them, right? But you don't know what that line means.
So this is a function. So the thing is, inside here, this is a function. We've not gotten to the function. Something is happening in the function. Inside here is a function. Something is happening in the function, right? So inside that function, right, we are recalculating this, of which you can actually still send. Okay, we are not actually recalculating it. We are picking this value, right? And based on the hypothesis we've gotten before, we want to measure it with our y, right? Our ground truth. Find the error, and based on the error, I don't know if you remember this formula. So this is the 21st time I'm writing this one. Right? What's continuing? Right? So this is your update with function. Am I right? So that is what is inside. So your J, what's the formula for J? Is it called for? Okay. Right? So what are we trying to obtain? Is that and simple. So you get what I'm trying to say now. So that is what is inside here. So you are updating what? Your weight. Because it is this weight that will make, if you get the correct values of the weight, that's when you'll be able to make good or fairly accurate prediction. Do you get it? Eh? It's simple. We are storing you. So whether it's minus, you get the negative value too. Right? So now we are going to do some updates to that, and then why are we doing this? Someone asked me this on Slack. So we are just doing this to save all the values of the costs, so that we know how well it is performing. Not like this function is not doing anything to our weight. This is like the raw cost function J, not the differential of the raw cost function. So we are just saving it to see how well our loss reduces during the training process. Do you get? So we are just saving it, like he said. I've forgotten the English that he used. What was that English that he used again? It's not listening to me, it's blinking. So, but you get what I'm trying to say now, right? So now we return theta and the cost function, right? And then this theta, by the time we have finished our training, is our what? The theta that we want, right? Okay, so this is the one that has this square. Okay, so this is the formula for the cost, which is what we wrote down there, right? It's the same as the one we were using before. Are we right? Are we? And this is the formula for formula for what? What's this formula, please? So that there's an error here. Where's the error? Nice. So now this is the update width, right? So for every time we come into this update width, the value of theta is going to change. Are you right? So once the value of theta change, we will make another prediction and see how well it predicts. If it doesn't predict well, we'll go again until the loss has reduced significantly. Or until it has reached its what? Local minimum. So I will be running all these things. Please let me run it so I will see how it goes. Yeah. Which one? I don't know. That's probably for 2 or something. Okay, now we have finished defining all our variables. We can train back. Right? I remember in that train function we are returning theta and what? The cost values, right? So the cost values, like what did I say? The cost values will give us a sense of what? The cost value will give us a sense of what? Nice. And the theta is what? What we are actually training. So in this we get this value of theta and you have trained it. If you like, carry this your theta to. So let me tell you the truth. See, the truth is this. So you see all these crazy Google stuff that you see before you finish typing hello how are you on Gmail, it has finished writing everything for you. All those fancy things that you're saying, it's just values of weight values that they saved somewhere. So anything you do, it trains. What does this person want to type next? And then gives you gives a result. That is what we are seeing based on theta values of weights that they have been able to save after they have trained their own model, right? So if you train, your theta is your theta. It will always, so why it is for the particular problem that you're trying to solve, it will always give you your result. So what people do most times is they deploy it to a web. If it's a very large value of theta, right? They deploy it to a web service. Or for simple ones like this, you can just write the formula in your web backend or wherever you want to use it, and then it gives you your prediction. You get it? Yeah, so now let's train. Alright, so my own is not training. This is your own training. Your own is training. So why is mine not training? No, it's not tired. It's tired. So it's because I didn't run this. Right? So my system is very fast. It's super computer. That's why it's finished. So now you notice, see how the loss is reducing. Guys. So it's reducing. 32, 31, 33. Is there anywhere it stops changing? Still reducing well, I mean?
Yes.
30, 29, 29.
Yes.
Does it get to 28?
No.
Let's keep going.
It stopped 29, 13, 8.
Still in 29 since so.
Yeah.
This is 1,000 iteration. So it's nice. Now see what is happening. 0.13822. 13822. 13822. So it's nice. The change is very, very, very minimal. Meaning that it has reached this what? Nice one. So now we pick the values of theta that we have gotten, right? I just put it in a vector form, right? Just spread it out. That's what you do. That's what theta the travel does. So these values is what we are going to use to make predictions. So this is that value of theta that I said, if you like, take it from anywhere you want to take it to. If you use it for prediction, it will give you your answer, right? Now let's plot the cost. Okay. So what does does it tell us? At what point were we wasting compute power? At what number? So this is the error, the cost function. This is the cost, and this is the number of iterations. So at what number of iterations were we wasting our time?
Maybe 400.
Yeah, 400. Right? Have you read what I did there?
I have a question. What if this shape is just like misread?
It's fine.
It's fine. That's very good.
So when you run it for a very long time, that's more than it. So now let's predict. So I've written a predict function. Right? The predict function is basically, what the predict function is basically doing is, what it is basically doing is this. So we know h is equal to theta 0 x0 plus theta 1 x1 plus theta 2 x2, right? Guys, this is the final part. So now we don't know, we know this is 1 normally, right? But we don't know this. We don't know this, right? In fact, we know everything here, right? But what are we bringing new? What are the new features we are bringing? Is your x1 and your x2. So what is going to make our model predict the correct house price? It is.
What's this with our model? What's this with our model?
What is going to make, so now let's assume that those values of theta that we have are there, are now here, right? And I now bring a house that is 200 square feet and 4 rooms, right? What is going to make this model, which parameter, which letter, which shape, which thing in this equation is going to make us predict the value of the house price correctly? Theta, fine. So those values of theta, you just carry them and put them in, right? If you have a new, somebody comes to you, an agent, says, okay, I'm looking for a house. What number of room are you looking for? 7-room apartment. Oh, 7-room apartment. How many, what's the size of the rooms that you're looking at? 250 square feet. Okay. I think the price is, just put your laptop on and just give the result. I think it's 700,000 naira. But you get what I'm trying to say, right? Yes. So that's what's happening. And that's true. So, sorry, I like talking too much. So, all those customer experience people that you see, that you just be asking me questions. You know, like, have you reading your mind? Or I don't know if you have ever called some customer. I'm not calling this our Nigerian one. Not our Nigerian one. But when they're asking you questions, they're asking you targeted questions. Have you ever experienced it before? It's as if they know what you want, or they know your problem. I don't know if you get what I'm trying to say. Have you met people like that before?
Yes.
Customer experience.
Yes.
Maybe you call their contact center and then you're talking, they say, okay, did you do this? Did you do this? The next thing they ask you questions. It's not as if they were following you up when you were having the problem or something. Have you guys ever experienced it before? So most of them, they have their own, maybe their CRM or maybe their software that has been trained to know what next to ask you. It's not like they have all those questions in their head. So now, when they ask you the question, you give them an answer, they type your answer down, right? When they type your answer down, they're able to say, oh, ask this person this next question or something. I don't know if you get what I'm trying to say. Based on that, they're already directing you towards what?
Like, I think there's a target audience.
Exactly. So it's not like they are witches and wizards. There's something that they are using under their feet. You get what I'm trying to say? So, there's another intelligence. You get? So, we are done. Somebody is looking at me. So, I'm now an agent. Who wants to buy a house? How many square feet? Eh? 7,000. 7,000. Room size. You see area now. Don't worry, I'll buy for myself. So number of bedrooms. So say the amount I'm going to pay. So now let's check if it's close to one of the things that we did before. Let's pick. So somebody should cram it. Not ready. Cram. Cram this one. 2, 4, 3. Average. $2,400. What was the answer? What was the price? Let's see how much. It's a regression problem. It's not giving the exact answer, it's not classification. But it's not, this is an approximate quality. It's about. It is about. So it's a regression problem. But you guys get the concept, right? It's not the exact value, right? Now let's say why it's not the exact value. Guys. Let me show you why it's not the exact value. Just like the one we did last time. It's a continuous something, right? So, how many, what's the size of this one? What's the size of this? Bedroom. What's the price? Oh, I even thought this was 999. But you shall just notice that, okay, look at this. This is 2, 4, right? This is 3. But check the price. Don't, if you're to use your normal, you're supposed to say this should be more expensive than this, right?
Yes.
But no, it's cheaper. So what? Okay. So what can you deduce from this?
There are other factors.
There are other factors, exactly. So the location of this place might be different from the location of this place. This might be Mushi, right? And this might be Ikeja. But I've not seen any VI here. There's no VI. There's no VI. But you get the point, right? So, okay, so what this is basically trying to explain to us is, yeah, now I'm enjoying it. So here, you guys will explore it by yourself because of time. The exam that I wanted to study the code for the next, so your guest maybe use 20 minutes. So I just want to see how the different values of the iteration affect how it is being, how it affects the cost, right? So you see these different plots. So when the learning rate is 1, when the learning rate is 0, when the learning rate is 2, right? And when the learning rate is 0.1, and when it is 0.01. So what you guys are going to do for me is this. So this is my assignment for you guys. You can study this one too. I think you taught it in class. Okay. So what you guys are going to do for me, my own assignment is this. I need you to explain why this is like this. Why this is like this. And why these two are like this. In fact, explain everything individually.
I will do the best way.
Eh?
No, look at the best way.
It looks like this is the best. That's what the assignment. So, thank you very much.
Thank you very much.
So So you are going to do logistic regression for the next 1 hour 30 minutes. It's simple, don't worry.
I wait 5 minutes.
So we'll set up. 5 minutes, take 5 minutes.